After more than 46 years, Voyager 1 sent back a terrifying new message that the space probe has detected an unknown object in deep space. This is a significant event. Could it mean that we have finally made contact with advanced life after all these years? In this video, we'll explore what Voyager 1 encountered in deep space. About Voyager 1. Voyager 1 is a space probe launched by NASA on September 5, 1977, as part of the Voyager program. Its mission is to study the outer solar system and venture into interstellar space beyond the Sun's heliosphere. It was launched 16 days after its twin, Voyager 2. Voyager 1 communicates with Earth through NASA's Deep Space Network, receiving commands and transmitting valuable data. Currently, Voyager 1 is situated at an impressive distance of 159.32 astronomical units, AU, which is about 23.834 billion kilometers away from Earth. This makes it the most distant human-made object in space, quite an incredible feat. Voyager 1 and Voyager 2. Voyager 1's mission is to explore and study the regions and boundaries of the outer heliosphere of the Sun, contributing crucial data to our understanding of space, particularly our solar system. It travels at a remarkable speed of 38,000 miles per hour, covering vast distances across space. For over 4 decades, Voyager 1 has been traversing space, far surpassing its projected time frame. It diligently records and transmits information about its travels every day. The spacecraft is expected to continue its interstellar journey until at least 2025, as it still has enough fuel to keep going. By that time, Voyager 1 is projected to have reached approximately 13.8 billion miles from the Sun. Both Voyager 1 and its twin, Voyager 2, were equipped with 10 unique scientific instruments. These include television cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, cosmic ray and charged particle sensors, and radio equipment for conducting experiments. Voyager 1 is equipped with various gadgets that have helped it endure a journey of 40,000 miles through Saturn's clouds, while Voyager 2 covered about 26,000 miles. Saturn is one of the biggest planets in our solar system, second only to Jupiter, and it takes about 29.5 Earth years to complete one orbit. Surprisingly, Saturn rotates on its axis in just 10.7 hours. In May of this year, NASA engineers faced an unusual problem. Voyager 1 started sending jumbled and ordinary statistics instead of the expected telemetry facts. Normally, Voyager 1 provides clean and easily readable data, but this issue has been persisting for some days now. The engineers see this as a major setback that could potentially end the mission, though they're not giving up on it just yet. Voyager 1 has been one of the most successful space missions, and abandoning it after all these decades would be like giving up on an impressive achievement. Recently, studies published in the space magazine Nature Astronomy News revealed that the gadgets on board Voyager 1 have picked up sounds of plasma waves. This is possible because the spacecraft has achieved 3 significant milestones: it passed the solar device's threshold, crossed the heliopause, and entered the interstellar medium. Currently, Voyager 2 still has 5 functional instruments, while Voyager 1 has 4 left. Nevertheless, both spacecraft are crucial for gathering valuable data about events in outer space. Before delving into the strange messages Voyager 1 has been transmitting, let's take a moment to appreciate some of its amazing discoveries. Alongside Voyager 2, it embarked on an interstellar journey and conducted a closer examination of Jupiter and Saturn, 2 of the largest planets in our solar system. The Voyager spacecraft performed exceptionally well, capturing never-before-seen images and amassing extensive data. The data gathered by Voyager 1 and Voyager 2 revolutionized our understanding of the mighty planets in our solar system. After completing its successful mission to Jupiter and Saturn, Voyager 1 said goodbye to its twin and ventured into interstellar space. Voyager 2, on the other hand, made additional stops along our solar system. In 1981, NASA made a corrective maneuver to guide Voyager 2 toward Uranus, and it reached Uranus in 1986, surpassing its expected lifespan twice during that time. On the way to Uranus, Voyager 2 discovered about 10 previously unknown moons, expanding our solar system's celestial family. Later, scientists directed Voyager 2 toward its ultimate destination, Neptune. At the time, Neptune was one of the farthest planets in our solar system, with Pluto being even farther. Voyager 2 captured more than 9,000 images of Neptune, revealing its surprise 9 moons. But that wasn't the only astonishing find. Neptune's largest moon, Triton, held even more surprises. Its diameter was not what we initially thought, and it displayed interesting features on its surface. Thanks to Voyager 2, we finally understood the brownish-white coloration on Triton's surface. It turned out to be geysers, volcanic formations that ejected liquid nitrogen, which then froze into white nitrogen snow when it landed on the moon's surface. These remarkable discoveries greatly enhanced our understanding of our solar system and the cosmic neighborhoods surrounding us. Since Voyager 2's visit, no other spacecraft has explored Uranus and Neptune up close. However, researchers continue to observe and study interesting phenomena surrounding these planets, even from a distance. Now let's uncover some of the mysterious spectacles that have been revealed on these distant planets. When it comes to ice giants in our solar system, we only have 2, Uranus and Neptune. But despite their name, they aren't just floating balls of ice. Instead, they're made of hot supercritical liquids containing volatile compounds like water, ammonia, and methane. Uranus, the second outermost planet, is about 4 times the size of Earth in diameter and takes around 84 Earth years to complete one orbit around the Sun. What's really interesting is that Uranus appears to be lying on its side. Scientists believe this happened due to a collision with a large object. A protoplanet in the past, but we can't be sure. This collision might have also led to the formation of its 27 moons. A decade ago, a massive white spot was discovered in Uranus's atmosphere, which turned out to be a huge storm with winds racing at up to 89 miles per hour. This storm was even larger than the United States. Uranus's ammonia clouds also reach freezing temperatures as low as -323 degrees Fahrenheit. Like Saturn, Uranus has a ring system, although not as grand. Neptune, on the other hand, is the outermost planet in our solar system, and it used to be the second outermost before Pluto's reclassification. Neptune is about 3 billion miles away from the Sun and is similar in size to Uranus, with a diameter of about 31,000 miles. Neptune is about 17 times heavier than Earth, while Uranus is about 14.5 times heavier. Due to its considerable distance from the Sun, Neptune has a very slow orbit period, taking around 165 Earth years to complete one revolution. To put this in perspective, if Neptune had inhabitants like Earth, by the time their civilization celebrates a new year, an entire generation on Earth would have passed away if they lived to the highest human lifespan. Despite its slow orbit, Neptune spins quite rapidly, completing one rotation around its axis in just 16 hours. When NASA's Voyager 2 visited Neptune in 1989, it made a fascinating weather discovery. The spacecraft captured bright bands of clouds and storms in the atmosphere moving at astonishing speeds of about 1,305 miles per hour. These incredible storms are thought to be caused by the solar energy deficiency Neptune experiences due to its great distance from the Sun. Scientists believe that these storm clouds might eventually disappear. During the Voyager 2 mission, scientists discovered the Great Dark Spot on Neptune, estimated to be as big as Eurasia. However, just a few years after its discovery, the spot mysteriously vanished. Some theories suggest that heat from Neptune's core caused turbulence in the atmosphere, tearing apart the structure of the spot. It's a puzzling phenomenon, and scientists are still trying to understand the mysteries of this distant planet. Scientists believe that Neptune's massive size implies it must have a very large core or heart. It's estimated that Neptune's core is about 1 to 1.5 times the mass of Earth, with temperatures reaching 13,000 degrees Fahrenheit and pressures reaching several million bars. Another intriguing aspect of Uranus and Neptune is their gravitational fields and characteristics. Unlike any other planet, their magnetic fields seem to deviate from the center and tilt towards the rotation axis. Scientists haven't been able to explain this oddity since its discovery. What we do know is that Neptune's gravitational field is 27 times stronger than Earth's, but for some reason, Uranus, despite its significant size and mass difference from Earth, has a weaker gravitational field. Both Uranus and Neptune are believed to have massive cores with high temperatures and pressure surrounded by dense layers consisting of ammonia, hydrocarbons, and water. Scientists have long been fascinated by the processes occurring under the immense pressure of these planets. One intriguing theory suggests that diamonds may be raining down in both Uranus and Neptune. While this may sound like a wild idea, diamonds are not just a fantasy. Industrial diamonds are in use all around us. To test this theory, researchers conducted an experiment using polystyrene, a plastic made of hydrogen and carbon atoms, to recreate the immense pressure conditions inside the ice giants. The experiment showed that the hydrocarbon compounds might indeed split under immense pressure, forming diamonds. The experiment created an incredible pressure of 1.5 million bars and raised the temperature to a scorching 9,000 degrees Fahrenheit. The result was an astonishing shower of tiny glittering diamonds falling from the simulated cloud. Almost all the carbon atoms joined together to form these tiny crystals in the simulator. The real diamonds formed in the atmospheres of Uranus and Neptune would be much bigger, produced on a larger scale, and under more definite conditions. These diamonds then sink to the planet's cores over thousands of years, leaving us with the fascinating thought of millions of years' worth of diamonds lying beneath the surface. The idea of diamonds falling as interstellar rain somewhere in the cosmos is simply mind-blowing and has always fascinated humankind. According to myths, when these precious stones were first discovered, they were considered a phenomenon that added to the intrigue surrounding these ice giants. Over the past decades, the Voyager 1 and 2 probes have explored a vast and mysterious region known as the interstellar medium, the space between stars that is sparsely populated. Despite the sparse population, many amazing discoveries are still being made. One such discovery is about the strength and direction of the interstellar magnetic field, which has led to heated debates among scientists about the shape and activity of the Sun's magnetic domain, the heliosphere. Initially, the heliosphere was thought to be shaped like a comet, but scientists now believe it is more like a sphere. Our space probes have provided answers to questions like what happens to the heliosphere when sunspots appear and disappear. When the solar wind, a flow of charged particles from the Sun, comes to a halt, it signifies the start of the interstellar medium. The ionized gas or plasma in this region can be likened to a rock in a river, pushing against the cooler, more dense plasma flowing around it. The Sun forms a cavity around itself called the heliosphere, and its edge is called the heliopause, where the sphere pauses. It's similar to how the top of Earth's troposphere is called the tropopause. In the Voyager mission, researchers initially had no clear idea of how far the heliosphere extended. During a Jupiter flyby, they gathered essential data that allowed them to understand the heliosphere better. At first it was assumed that the heliosphere would reach only up to Jupiter, since Jupiter is only 5 times farther from the Sun than Earth. However, as the Voyager spacecraft continued their journey, they found out that the heliosphere extended much farther, even beyond Neptune. It was a surprising discovery, and no one knew exactly when or where the spacecraft would enter interstellar space. Don Garnett, a researcher from the University of Iowa, reported that shortly after Voyager 2 passed Neptune, it detected signs of the heliopause in the distance. The spacecraft picked up strong radio waves in July 1992, which turned out to be caused by significant solar flares that occurred about a year before. Researchers later found that the plasma from these flares had reached the heliopause, causing electrons to oscillate and release radio waves. The frequency of these radio waves indicated a density matching what was expected for the interstellar medium, revealing that the local interstellar medium is much denser than the outer heliosphere. From Earth, this finding shed light on the fascinating boundary where our solar system meets interstellar space. The local interstellar medium might seem like a vacuum, but it's actually quite thin. To determine the distance of the heliopause from the Sun, scientists need to calculate the speed of outbound solar material and the time it takes for this material to hit the boundary. The heliopause is found to be about 177 astronomical units away from the Sun, which has given us valuable insights into the outer boundaries of our solar system. Voyager 1 provided some hints that it had left the heliosphere, like a decrease in high-energy particles from the Sun and an increase in cosmic rays from beyond the solar system. However, some researchers remain uncertain about this claim. One problem is that Voyager 1's plasma instrument stopped working, making it difficult to measure the sudden increase in particle density when leaving the heliosphere. Additionally, the expected change in the direction of the magnetic field did not occur. On November 15, 2018, Voyager 2 achieved another important milestone by successfully crossing the heliopause. This time, there was no doubt, as its plasma instrument was still functioning well and recorded a significant increase in particle density. Voyager 1 continues to transmit data frequently and appears to be in good shape. However, it's possible that the spacecraft developed a condition called electronic aphasia, which impairs its ability to transmit smoothly. Thankfully, scientists have found a way to address this issue. Voyager 1 has been a true pioneer in space exploration, venturing beyond our Sun's magnetic field to bring us knowledge from the other side. It has endured tough conditions to provide us with valuable information that expands our understanding of the interstellar space.